Hey everyone, so going into Unit 4, Lesson 2, how to solve systems with multiple variables. Still dealing in linear equations for now, so just a reminder, this is an example of a linear equation. Even with the square root here, the square root's on a number, but each variable has just a single power, and they're separated by addition or subtraction. Whereas this one is nonlinear. Because you have a variable underneath the radical symbol, and because we have the product of two variables together, which is not allowed in a linear function or equation. And so just recognizing those facts when we're identifying if a system is a linear system or a different type of system, because that will affect the possible answers. All right. So here's just two examples of a linear system of equations. Note that now that we have three variables, we have to have three equations. And so that's kind of just a good general rule to have. However many variables you have, you need that many equations to be able to solve for all three of them. This one obviously getting a little more complicated because there's three variables in all three equations. And so there's two ways to solve these. You can use a substitution method. Or you can use elimination. It really just does depend on the problem itself. So for like this problem here, I would really focus on elimination, while for this one, substitution is going to be the easiest way. So for example, here is that first problem. The textbook calls this like the triangle method. I've never heard that before, but back-to-back substitution, I think just because it looks like a triangle, because we already know the value of z. If 2z is equal to 6, then z is equal to 3. So we can just take that 3 and plug it into that next equation, because negative y plus 3 times that 3 that we can just substitute in right there is equal to 9. All right, so then we can just solve that out. So negative y plus 9 equals 9. Well, those are going to cancel to 0, so y equals 0. All right, and now we have two variables. So out of the three, we have two of them. And so if you haven't guessed it already, that next step is just to now substitute both of those values in. So x plus 2 times 0 plus 3 is equal to 7, where I've plugged in the 0 and the 3 for the y and the z. Okay. And so we simplify that out. X is equal to 4. So subtract 3, that goes to 0. And so your solution set goes in alphabetical order. We got 4, 0, 3. Excuse me. All right, so probably the more basic method, because you're really just evaluating. You're plugging something in, solving it, plugging two things in, solving it. Where it gets a little tricky is when we don't have just a ready-made variable for us. So something like this. We have no way of knowing what is z, what is y, what is x, or anything. And so we have to use like the Gaussian elimination method, and don't get scared by the name. It's just the mathematician who figured it out. And so what we're going to do is we're going to pick one variable to eliminate. We want to pick that variable consistently. So you settle on a variable right from the get-go. You're going to stick with that one all the way through. So you don't always have to go with the very front one. You could just as easily do y or z with this one. But yeah, so just pick one. So I might say eliminate x from equation 2, in that this is 1, this is 2, and this is 3. All right, so Okay, well, to do that, I'm just gonna add it to equation 1. And I will always cross my z's so you can tell them from my 2's, especially in this program. Okay, so we're just going to add these two together. The x's cancel. That goes to y plus 2z is equal to -1. Okay, so we have created a new equation 2. So think of this as new equation 2. All right, well, whatever I chose, I need to choose that again. So maybe now I want to eliminate x, so these have to match, from, let's do equation 3. All right, these should not match. Those should be different. I already eliminated it from equation 2. It doesn't mean no good to do it again. All right, well, 2 and 3 would be good ones to match up because they already have opposite signs if you prefer to add instead of subtract. So I'm going to match up equation 2 and equation 3. All right, so there's equation 2 and equation 3. And what you should notice, if you haven't already, is that this is not already set up to eliminate. If I add these together, the x's don't cancel out. And so I have to multiply through, which is what we talked about in lesson 1, by a value that will get it to. So I'm going to use 3 here. That'll make it 3. And make sure you go to everything. So 3z and then -9, every single term. All of these, nothing needs to multiply, but beware, sometimes you do have to change both equations and not just one of them. And we're going to add down. So we get 7y plus c equals -7. And so we just added everything down. Think of this as your new equation 3. So we have a new equation 2, and we have a new equation 3. So your next step is to match your new equations. I'm just going to abbreviate that EQ. My stylus is going a little slow tonight. And so we have y plus 2z equals -1. And we have 7y plus z equals -7. And then we're going to solve. So you can use substitution or elimination from this point to solve this system, because this is just like yesterday's systems where we have 2 variables and 2 equations. I tend to just stick with elimination all the way through. I'm already on a roll with it, but it really doesn't matter. So I'm going to multiply this bottom one by 2. Then I'm going to subtract. All right, so y minus 14y is -13y. The z's cancel, and I get positive 13. So y equals -1. All right, so we have our first variable. All right, now it's really just a matter of, once you have the first variable, once you have your first variable, you're going to pretty much follow the trend of example 1. So we need to go to one of our new equations here and plug that in. I'm going to use this first one because y is by itself. So -1 plus 2z equals -1. So z equals 0. So there's our second variable. And then we just go back to one of our very first equations, probably the very top equation here, and plug those in. So, okay, so plugging in y and z. So x plus 1 essentially is 2, so x equals 1. And so I know I kind of came up here with that, but the solution to this system then is 1, -1, 0. Sorry for the lack of space there. Should have scooped that problem. But anyway, and so that's pretty much the gist of it. They get a little complicated every once in a while. You'll get one with no solution. And sometimes you'll get one with infinitely many solutions. You'll recognize those no solution ones when something cancels out and you get a false statement. So remember, anytime your answer is false, it's no solution. And I'm not going to outline step by step this, but I'm going to match equations 1 and 2 here and get rid of my x. So 2. And this is only because I know where this answer is going. You may not get this right away. You may have chosen to get rid of the y first. And we're subtracting down here. So there's one new equation. And then I'm going to take 1 and 3 and get rid of the x again. I'm going to multiply 1 by 3. And then subtract down once again. Realizing I made a mistake here. When I distributed, I did not multiply this one. That should have been a 4 because I multiplied everything by 2 the first time and then by 3 the second time. So that was my fault. So this is 3. Okay, so now if I match those together, you'll see so 3z equals -4. And then 2y minus 3z equals -2. You should be able to see the same thing is not equal to the same thing. But if we subtract down, we get 0 equals -2, which is false. So there is no solution. Or the answer is the empty set. And so if that happens anywhere throughout your problem, it's always no solution. Infinitely many solutions is a little bit different. I'm going to get rid of x again. Please don't think you always have to. I just know what these are going to do. And so I'm going to match 2 and 1. So I'm going to multiply by 2. So 2x minus 2y plus 10z equals -4. So you saw up here, that one mistake, had I not already known where this problem was going, would have messed up the entire rest of the problem. So really double check your work here. 2x plus y plus 4z equals 2. We're going to subtract down, so we get -3y plus 6z equals -6. And then I'm going to do 1 and 3, and again, get rid of my x's. And so I'm going to multiply by 2 again, so it's the same equation that I just used. So I could have matched 2 and 3 because they already matched, but again, I know where this is going. So that cancels, that goes to -6y. We're subtracting, so 12z. Watch your minus your negatives. Equals 12. And so when we put these equations together, and I'm just going to bring this one over here for the purpose of space. We can eliminate if we multiply through this top one by 2. So that gives us a new equation. Here we have -6y plus 12z equals -12. I promise I'm getting to the point here. -6y plus 12z equals -12. So you can see, hopefully, when you add those down or subtract those down, they are identical. And so you get 0 equals 0. And so the minute you get that true statement, this problem now has infinitely many solutions for one of those variables. And it then has what's called a parameter. And so here's kind of how parameters work. If we continue the same problem and we look at, let's say we look at this new equation here. So we have, let me switch colors one more time. We have a negative 3y plus 6z equals negative 6, right? If we solve this equation for y, then we get negative 3y equals negative 6z minus 6. So y equals 2z plus 2, all right? And let's go back up to our first equation. And now let's get x in terms of z as well. So x minus y, and y happens to be this, so minus 2z plus 2 plus 5z equals negative 2. And it would have mattered which one I chose. All right, I chose the first one, but again, it doesn't matter. Because if we solve this, then we get x minus 2z minus 2 plus 5z equals negative 2. So x plus 3z equals 0. So x equals negative 3z. All right, so now we have both x and y in terms of z. And so here's how a parameter works. If x is equal to negative 3z and y is equal to 2z plus 2, and z, we're going to let z equal t, where t is our parameter. And all that means is that t can be any real number. And that is justified with this statement right here. All right, so any real number is justified by the fact that we got 0 equals 0. So let's say, for example, your parameter is 2. Then x would equal negative 6. Y would equal, that's 2 times 2 is 4, plus 2 is positive 6. And z would equal 2. All right. But you could make a whole table where you say, okay, t is this value. So 2, 5, negative 1, whatever value you want it to be. And you can find the solution for x, y, and z. Those would be your solutions within that parameter. So if you ever hear the term parameter when they're talking about math, that's what they're talking about. Okay. But this is going to have infinitely many solutions, all real numbers. All right, then of course the last thing we're going to look at real quick, and I've gone a little long again, is applications of this. So same process of solving, but making sure that you can read and know how to set these up. Okay. So a biologist is performing an experiment on the effects of various combinations of vitamins. She wishes to feed each of her lab rabbits a diet that contains 9 milligrams of niacin, 14 milligrams of thiamine, and 32 milligrams of riboflavin. You have doctors as parents, don't let them hear me say those words because I'd probably butchered them. She has available 3 different types of commercial rabbit pellets. Their vitamin content per ounce is given in the table. How many ounces of each type of food should each rabbit be given daily to satisfy the experiment requirement? Okay, so here's what your equations would look like, and these numbers came straight from the table. So these are all our A's, these are all our B's, these are all our C's, and you can use X, Y, and Z. But with word problems, they usually give you, like, you usually have letters in there that would make more sense for your problem. And so we had the totals of these up here in the problem. So this, we had a total of 9, a total of 14, and then a total of 32. So we're adding the types together to get how many total milligrams there are. All right, so then you just solve using the method above. You're welcome to stop the video now if you know how to solve it, or fast forward to the solution. I'm going to walk through this one more time. So choose 2 and choose a variable to eliminate. I'm going to switch it up a little bit, and I'm going to eliminate B. Because these two already match, and this one is just a multiplier of 3, and so they're easy to eliminate. So I'm going to eliminate B. So I'm going to take 1 and 3 and match them together first. And I'm going to subtract down. So it'll be minus. Okay, so A minus 60 equals 23. I went ahead and matched up 1 and 2. You could do 2 and 3. It doesn't matter. And I multiplied equation 2 by 3. So 9, 3, 9, and 42. Same thing, we're going to subtract down. You could subtract up if you want to keep more of your numbers positive. It really doesn't matter what order you put these in. It all comes out in the end. So makes it easier for some of you that struggle with negatives. Okay. So this is our second new equation. So we're going to take our new equations and match them up. So we get, and I'm actually going to go ahead, hopefully this won't throw you off too much. I'm going to go ahead and multiply through by 7 and get rid of my A's. And bring this one over as well. And hopefully I've done this right to where it will work out. And we're adding down this time. If you didn't notice that, those were opposite signs. So we're adding. So 194. Shoot. All right. Sorry, guys. I lost my negative sign, which changes this number to 128. It doesn't help. Goodness gracious me. We subtracted here too. I lost 2 negative signs. So that is also negative. So my first number was right. Negative. Oh, goodness. Sorry, guys. Watch your signs. Don't do what I do. What I have, 194. So negative 194. There we go. Divided by 50. Check yourself periodically to make sure you're getting the right things. I'm going to have to edit this video because I'm still getting the wrong answer somewhere. Okay. Racking my brain, but I checked the answer in the back of the book. I didn't make a mistake. This one just has no solution. It's impossible. I mean, I made mistakes, but it actually is impossible. Okay. Sorry, I kind of picked a bad example for your notes there, but they've gotten kind of long. So the gist is how to set it up. If you can do this, then the solving part is the same as the other one. So it's really just a matter of getting them set up properly. So I'll leave it at that. Have a good day. Let me know if you have questions on your homework. or anything else. Thanks.